Hello guys, welcome to another brand new tutorial series on Next.js, and more specifically we'll be working with Next.js 14 and above that. Okay, and this tutorial is built for absolute beginners as well. So let's get started. So to first work with Next.js, we first have to understand why Next.js. Let us see what are the differences between React.js and Next.js. React is not really created for building full-featured production applications. Okay, so it is just a library that helps with UI components. That is all it is. Okay, so React is just a library which takes care of one small part of building a huge application, which is just the UI. If you are working with React, you need to use external packages and libraries for things like routing, data fetching, etc. So for example, if you want routing to be added to your application and you are using React, you need to install another package called React Router DOM. You also need to install additional packages and tools like Webpack, Babel, React Router DOM, etc. for various bundling, compiling, and routing features. No best practices and standards are enforced. And I'm not saying that there are not any best practices working with React, but the problem is that the standards are not really enforced. Let us now look at the Next.js side of things. It is a React framework. It uses React for building UI components. It provides everything else needed to build production-grade applications. For example, bundling, compiling, optimized rendering, routing, etc. It is all part of Next.js. No need to install additional packages as Next.js already provides everything you need. Also, conventions, certain best practices and conventions need to be followed to implement some of the Next.js features. So the advantage of doing this is that since the conventions are actually enforced by the Next.js package itself, you can actually have a uniform sort of a way of working for larger teams or larger companies. So let us now see why learn Next.js. Next.js is a React framework for building production applications. It simplifies the process of building a web application for production. Because earlier we saw that if you're using React, if you want some other feature like routing, you have to install it separately. But since you're using Next.js now, the routing is also part of Next.js itself. So it simplifies the process of building a web application. So let us see some of the other features that Next.js provides, which makes it so much easier to build the web applications for production. Okay, so let's look at the first one. Data fetching. Next.js offers very easy to use data fetching features which support async await. Routing. Next.js offers a very simple file-based routing. So we don't have to use React Router DOM. But because you're using Next.js and Next.js has a file-based routing system, the process of writing routes is simplified a lot. Next.js helps so much with rendering because Next.js helps with client-side as well as server-side rendering. And the reason why in some cases server-side rendering might be so important is because the pages are pre-rendered on the server and sent to the client. And because of this, the SEO scores also increase. API routes. With Next.js, you can also write a lot of API routes. And because of this, not just for front-end, you can also use Next.js for back-end as well. This makes Next.js a complete full-stack application. Styling. Next.js supports all popular styling paradigms like CSS in JS, CSS modules, etc. etc. And the next one is optimization. Next.js also offers a lot of optimization features out of the box. For example, if you're loading a script or if you're loading images or fonts, Next.js makes it a lot more quicker because it is built right into it. So before we proceed forward, there are a couple of prerequisites for learning Next.js. Let's look at what they are. So the first thing is a basic understanding of HTML, CSS and JavaScript fundamentals. And when we talk about JavaScript, it would be helpful if you are familiar with ES6 syntax. And you also need to understand how React works. For example, how is the state managed? How are the props being sent inside of the components? How do hooks work? And how do JSX work? Okay. So in the next section, let us see how we can build a very simple hello world application using Next.js. So now let us go ahead and build our own very first Next.js application. So to do that, you need two things. One is Node.js. So just go ahead and install Node.js by going to this particular URL, nodejs.org. So once you're done with this, go ahead and install Visual Studio Code. This is a code editor, but you can choose pretty much anything that you want. But this is what I would recommend. So what I have now done is that I've just created a folder called Next.js course in my machine. And then I've opened that particular folder using my Visual Studio Code. So now to install Next.js, you just have to put in a very simple command right here. And the command is npx create next app at latest. And that's it. Okay, just go ahead and press enter. So it is asking for the project name. I'm fine with it saying my app. So I'm just going to go ahead and press enter. So it is asking for, would you like me to use TypeScript? Yes. Would you like to use ESLint? Yes. So the next one is Tailwind CSS. Yes, I want to use Tailwind CSS. I want this particular directory as well. This is very important. I'm going to go ahead and say yes. This is the new feature that has been introduced in Next.js. I'm definitely going to go ahead and say yes. So would you like to customize the default import alias? I'm going to say no for that. And that's it. So just give it a minute or two. Okay, so once it is done, you can actually see that a new folder has been created. It says my app and it has all the necessary files and folders. Do not worry about all the files in the folders. We will explain all of that in the next section. But for now, let us just do a simple hello world application. Okay, so to run this particular Next.js application, all that you have to do is say npm run dev. Press enter. Okay, it says that it is missing the script because we are not really in our directory. We are actually in the parent directory. So what I'm going to do is I'm going to come inside of my directory, which is this my app, and then execute the same command, which is npm run dev. So if you want to look at this application in your browser, you just have to copy paste this in your browser, or you can just press Control or Command if you're working with a Windows or a Mac machine. Press it and that is going to open up a new tab for you. So great, now you can actually see that the next application is running. Now, if I want to change, let's say this Next.js, or if I want to change this get started by editing this particular text to hello world. Okay, so if I want to do that, I'm just going to go inside of this particular folder right here, which is source. Do not worry, we will be talking about each and every single file in depth in the next section. But for now, I'm just going to go inside of the source. And then inside of that, there is another folder as well called app. So inside of that, you can actually find the page.tsx file right here. Okay, click on it. And you can actually see that this is where the home component is present. Okay, so this is the home component. All the UI that you see right here is coming from this particular component right here. So now I'm just going to remove this particular line right here. We do not want this. And I'm going to remove this particular line here as well. And instead of that, I'm going to say hello world right here and save it. And then let's look at the tab right here. See, you can actually see that hello world is printed. So now that we have printed the famous hello world in our next project, let us now go ahead and try to analyze what are the folders and the files that are actually present right here. We've got 4 folders right here and we've got close to 10 files right here. So we have the gitignore file. Basically, we can put in whichever files that we want Git to ignore. And we've got the tsconfig file, which is the configuration file for TypeScript. And we also have the Tailwind configuration file, which is to configure Tailwind in our application. And we also have the post CSS file, which is also related to Tailwind CSS. And then we have the next.config.mjs file, which is the configuration file for Next.js. And then we've got another next env.d.ts file, which is where we actually declare the TypeScript types for Next.js. And then finally, we'll come to the most important part, which is package.json and package.lock.json. Okay, so let's first look at the package.json file. So right here, you can actually see that these are the scripts and these are the dependencies. So we've got the dev script first. So what this script does is it is in charge of running the Next.js application inside of our local. And if you recall, that is what we did to run this particular application. Okay. And then secondly, we have the build script. So we run this particular script when we want to build our Next.js application to deploy it to production. And next we have the start script. We use this particular script to start the application that's been deployed to production. Okay, so that is why we use start. So finally, we have the lint script, which is something that we run before we deploy it to production, just to make sure that our code is following all best practices. Now, let us look at the dependencies. So we've got the React and the React DOM, which is what Next.js is built on. And then we've got the next package here as well. So now let us look at the dev dependencies right here. So here we can find many things right here, and these are depending on, what are the options that you chose when you set up Next.js project. Okay, so depending on what I chose, I can find TypeScript right here and all the types that are required for all my dependencies right here. Okay, and then we have the auto prefixer, we have the post CSS and the tailwind CSS files right here. These are the absolutely essential dependencies that are critical for the application. Without this, the application is not going to run. And then we have developer dependencies right here, which is to make our own life as a developer easier. Now, let's come back to the folders right here. So this first folder that you see right here, this folder is generated when we build this particular application. Okay, when you run this particular build script right here, this folder will show up. Okay, and this folder is what we're going to be deploying to our production. And the reason why we are able to see this right here, even though we have not run this particular build, is because every time we run the dev script, this will internally build all these files and then put it here. And one more thing, this folder will not be considered by Git because this will be a part of the git ignore file. So you don't have to worry about this being pushed to GitHub. Let us look at the second folder, which is node modules. This is the result of installing all these dependencies and developer dependencies right here. And the reason why this showed up even though we did not put npm install is because when we run this particular script, it automatically internally installs all these dependencies and creates the node modules file. Okay, now let's come to the third folder, which is the public folder. Here, this is where you put all the images and the SVGs. Let us now look at the fourth folder, which is the most important folder, which we'll be spending most of our time on, which is the source folder. We have app folder inside of source. And the first one is the fav icon. This is what will show up in this area right here. Okay, and then we've got the global CSS, which is the CSS applied for all over the application, and we have the layout.tsx, and this is a component that will be available across all the pages. So if there is one particular component that you want available across all pages, you can actually put that component right here. Let us now look at the last file, which is the page.tsx file, and this is where the home component would sit. This particular home component is what is actually being passed inside of this children right here. So this would be the home component, and that will be available right here. And that is why we are able to see this page.tsx home component when we run npm run dev right here. Okay, so I'll tell you what is the flow of control. So whenever we enter npm run dev in the terminal right here, the control flow first comes to the package.json file right here. It first has to look what is the script actually mean, right? So npm run dev means that this is the dev script, and then it sees what is the command that needs to be run. And as soon as this command is run, the control flow goes to layout.tsx file, which is the root level component. This is very important. This is where everything starts. And what did I tell you earlier? This children, it is always going to be whatever it is that we specified inside of the page.tsx file. So page.tsx file is going to be listed. It is going to be displayed right here. I hope you understood. Even if you do not understand it, do not worry. We will be going much more in depth in the next sections. And I'll see you in the next section. So in the previous section, we saw how to set up a Next.js project, and we also saw what are the files and the folders that are included when we set up our Next.js project. So now let us look at how routing is being done in Next.js. So routing in Next.js is done through convention than configuration. So what does this mean? So when we talk about convention, we can also call it as a rule or set of rules that Next.js has set for us. So as long as we, the developer, follow these rules or conventions, the routing is going to be so much easier. So we don't have to focus on configurations or anything of that sort. Because if you think about it, in React, if you want to do routing, you have to install some third-party packages and then configure them, right? But in Next.js, we don't have to do any of those configurations. We just have to follow some conventions, and that is it. Okay, so let us see what those conventions are. So the first thing is that the routes must be put inside of the app folder. So if you remember, the app folder sits inside of the source folder. Let us look at the second point. Every file that represents a route must be named page.js or page.tsx. So this depends on whether you're using a pure JavaScript file or using TypeScript inside of it. So the last one is each folder represents a path in the URL. So if this is a little obscure to you, do not worry. We'll actually take you through a very simple example. And as we do these things, this will become so much more clearer to you. So let us build these paths. So if you see right here, we have the root URL right here, which we can also consider it as the home page. So we also have the about page and we have the contact page. So let us now actually see how we can build these paths in Next.js. So first thing is, let us actually go ahead and build this particular path. And whenever the user goes to this particular path, we can just display some text saying that welcome to the home page. So this is the project that we had earlier set up. So if you see, I've removed all the files and the folders that were inside of the source folder. So let us actually start afresh. Okay. So if you want to build a particular page that needs to be showed when the user goes to this URL. So the first convention that we need to follow is that, let's look at the first one. Routes must be put inside of the app folder, right? So let us actually go ahead and create the app folder. All right. So now we know that all the routes that we want should sit inside of the app folder. Let us actually look at the second one. So every file that represents a route must be named page.js or page.tsx. So to represent the localhost port 3000, we can just create a file called page.tsx. So let's go ahead and create a component right here and export it as the default. So to do that, I'm just going to use this shortcut rafce. Okay, you can easily do this if you've installed this particular extension right here. Okay, so let's go back. We always want to name this something meaningful. We don't want to just say page because our readability will get affected. So I'm just going to go ahead and name it as home. Okay, and I can just say welcome to the home page or something like that. Now, so let us actually go back and check if it is actually reflected. Perfect. Now you can actually see that the text is displayed. Now you can actually notice that this layout.tsx is automatically generated. Just notice that it automatically gets generated. We'll discuss more about it in the upcoming sections. So let's come back. So now that we have done this first particular URL, let us now actually look at how to do this particular path right here. So to do this about path, you cannot just go ahead and create an about right here and expect it to work. Okay, you cannot do that. So if there is a new path that is getting added, this always needs to be put inside of a separate folder. Okay, so each folder represents a path in the URL. So if you want an about right here, you have to create a folder called about, and inside of that folder, you have to put this particular page that represents that folder. Don't understand it? Don't worry. Let's see it in action. Let us go ahead and create a folder called about. So now that we've done that, I'm going to create another file inside of it called page.tsx right here. And I'm going to do the same thing that I did previously, which is rafce. And I'm going to call this about. So I can change the text to about page. That is it. So let us go ahead and test it. So I'm just going to say about right here. And you can see that it automatically changes. So what did we understand from this? So whenever there is a new path, always create a new folder and then put a page.tsx or a page.js inside of it. Okay, but now you might ask, why didn't we put this particular root URL inside of its own folder? And the reason why we did not put this inside of its own folder is because it is the root URL. So now let's do the same thing for the last URL, which is the contact URL. So to do the contact URL, I'm again going to create another folder right here called contact. I'm going to create another file called page.tsx. And I'm going to use the same snippet. And then I'm going to call it contact page or contact. We can call it contact page. So let us actually go ahead, and the contact page is getting updated. So you can do this for n number of paths. So you might also have a question. What if I go to a path that does not really exist? So for example, let's say I want to go to the terms and conditions page, but we don't have a terms and conditions folder. So that path wouldn't exist as well, right? So in that case, what would Next.js do? So let's say I type terms and conditions. See, Next.js automatically generates a 404 page. So you don't have to do anything about it. So I hope you understood how simple routing works. So we'll take it up a notch in the next section by seeing how nested routing works. So in the previous section, we saw how to create these paths. So let us actually in this section take it to the next level. Let us actually see how to create these paths. So this particular path represents a list of all the blogs. And then this path basically takes us to the first blog. And this path takes us to the second blog. So let us see how to do that. So let us first create a folder called blogs right here. And now that we've created the blogs path, we have to mention what should we represent in the web page when the user goes to this particular URL. And we can do that by creating the page.tsx file right here. And now I'm going to default export a component. So I'm going to call it blog list. All right. So this is a list of blogs. So let us actually test it out. So I'm going to go to blogs right here. So as you can see right here, it is actually working fine. So right now, if I go to the first blog, you can actually see that this page does not exist yet. So to create this new nested path /first, what you can do in your folder is that go inside of the blogs folder. Okay, so this is the root, right? This is the root. Let it be where it is. So I want you to create another folder right here called first. Okay, and that's it. So what is the content that we want to show when the user hits this particular URL? So to mention that, we again have to create the page.tsx. So let us export a function and we can call it as first blog, right? So we can actually say first blog, right? Or this is the first blog. Okay, something like that. So let us actually hit it again, and you can actually see that this is the first blog. So let us now create the second blog right here. So if I want to create a second blog, I can just create another folder right here and then say second. All right. So what do I want to represent in the page when the user goes to the second path? So I can create another page.tsx file. I can either type everything out or I can just say rafce, and then I can call it second blog, right? I can say this is the second blog. And let us now go ahead and try it out. So if I hit second, you can actually see that this is the second blog is coming right here. And that is how nested routing works. But now you can imagine that this is not the most optimized way of doing things, right? So for example, if there is like 1,000 blogs, it is not feasible to create 1,000 folders like this. I mean, you can go ahead and do it, but that is not the most feasible way. So the way that we can handle this particular problem is by using something called dynamic routing. We'll be talking about this in the next section. So in this section, let us see how we can make use of the dynamic routing feature that Next.js offers. So earlier in the previous section, we created paths for these 3 URLs right here. And the way that we did that is by creating separate folders for the first blog and then the second blog right here. So we created the first blog folder and then we created the second blog folder. But when we think about production applications, there could be 500 blogs, right? There could be 1,000 blogs. So in that case, it is not feasible to be creating different folders for every single blog, right? So we need some dynamic way of doing it. And that is where dynamic routing feature in Next.js comes in. So to illustrate the dynamic routing feature, let us actually take a different example. Let us try to build these 3 different paths. So firstly, we want the products path, which is basically just going to list out all the product names. All right, very simple. And this path represents the first product. So whenever the user goes to this particular path, all the product details of the first product is displayed. Okay. And same thing for this path as well. So whenever the /2 is hit, all the product details of the second product is displayed. So let us actually see how we can do that. So first off, what I'm going to do is I can create a folder called products. And since this is the root directory of products, I'm just going to create a page.tsx again. And now I can define a default component by saying rafce again. And I can call this product list. Okay. So this could be the product list. And now I can display a few products down here. It could be product 1. It could be product 2 and product 3. Let me wrap this with a React fragment. Let me move this inside of this. All right. So let us actually test the products path out. So I'm going to go to the products path right here and press enter. And now you can actually see that the product list displayed. Now, if I were to go to the first product right here, you can actually see that this page still does not exist. So the first way of doing this would be to basically just go in here and create a folder for the first path. So this is the first path. So what do we want to display when the user goes to the first product? I can create another page.tsx right here. And then I can create another default component saying array_fce and then say product details, right? I can call this particular component product details. It really does not matter what you call these components because they are default exports anyway, but you can try to be as specific as possible for readability. Details of product 1. So now if I press enter again, you can actually see that details of product 1 is listed. But if I were to go to the second product, it would still not be available. And to do this, I might have to create another folder right here, right? So I might have to create another folder, and then I might have to copy the contents of the first page, create another page inside of this, and then I might just have to change the content. And then now if I press enter, you can actually see that details of product 2 is present. But obviously creating separate folders for every single dynamic path is not the most smartest way of doing things. So let us actually see how dynamic routing works in Next.js. So let me remove both these files right here. So to introduce the dynamic routing feature of Next.js, what I'm going to do is create a folder and I'm going to use this particular notation. So I'm going to be using the square notation, and inside of the square brackets, I'm going to put the product ID right here. So this product ID is mapped to whatever it is that we put right here. Okay. So earlier we saw that we were creating the first folder and then the second folder and then the third folder, right? So we are not doing all of that right now. Okay, so we are not doing all of that right now. We are deleting it. But instead of all of those folders, we create this one common folder right here. So now whichever product ID that we specify, it could be 2 or it could be 5 or it could be 10. It is always going to be mapped to this particular folder right here. So now let us specify what needs to be represented when the user goes to whichever product ID. So to do that, I'm going to do the same thing again. I'm going to say page.tsx and I'm going to use this particular snippet. And I'm going to name it product details. And now I can specify details of the product. So now let us actually go ahead and test it out. So it does not matter which product ID that we specify, the control is always going to go inside of this particular dynamic folder. So we can call this the dynamic folder. If I were to mention 10 and press enter, it is always going to show the same text that we mentioned instead of this. Okay. Now, if I were to go to 12 or if I were to go with 15 or pretty much any product ID, we are always going to be showing the same UI, right? But this is not the most ideal way of doing things, because normally in production applications, the way these things work is that we first get the product ID and then we make an API call, fetch the product information, and then we display it. But for the purpose of this illustration, I want to do one thing. Whatever product ID is mentioned right here, so in the UI as well, I want that number to come. So for example, details of the product 15. If I put 20 right here, it needs to say details of the product 20. So let us now see how we can do that in code. So Next.js allows you to access whichever product ID is requested in the URL inside of this particular component. Okay, because as you see, this particular file is sitting inside of this product ID. So this page.tsx, which is this particular component right here, has access to the product ID, which is the parent, right? We have access to the product ID in the props that is being received right here. So inside of the props, we have another property called params. So I'm just going to destructure the props and get the params property out of that. So this params is an object, and inside of that object, we have access to the product ID. So the way that we can actually represent that is we can just say params.product ID. So let me save it and let me run this again. And now you can see that this 20 is being reflected here. So if I were to change it to 3 or if I were to change it to 5, you can actually see that this particular product ID is passing inside of here, and we're accessing the product ID through the params object. Clear? You can also notice that there is a red squiggly line right here, and this is because of a TypeScript error. So to make this error go away, we can specify the TypeScript types. So we can just say that this object, this entire object denotes the prop object. Inside of that, we get the params property, which is also going to be an object. And inside of this particular object, we get access to the product ID. So we can mention the product ID, and the type of this product ID is always going to be a string. So if we mention the string, you can actually see that all the type errors are getting resolved. And that is it for dynamic routing. So let us do a quick summary of what we had learned in this section. We saw that it is not feasible to be creating separate folders for every single product ID. So instead what we did was we created a folder using this particular notation with product ID inside of it. We can also just say ID inside of it, but we wanted to be a little bit more specific and say product ID because that would help with readability. And after we created the folder, we created another page.tsx file where we dynamically showed whatever the product ID has been requested for. And we were able to do that using the params object that we were getting from the props object. And that is it for this section, guys, and I'll see you in the next section. So in the previous section, we saw how we can achieve URLs of this particular structure. So as you can see right here, we've got the products and then the product ID specified right here. So whichever product ID that we specify right here, the product ID details are going to be listed right here, right? So as you can see here, we've got the details of the product 10. So if we were to enter 15 or whatever product ID, that is going to get reflected in the screen. So in this section, let us explore another concept that Next.js offers, which is called nested dynamic routes. So what do I mean by that? So as you can see right here, this is the URL that we achieved in the previous section. So now let us look at a URL that builds on top of this. So it starts with this, and then we add another thing right here. So basically what this URL means is that we are going to the first product ID right here, and then inside of the first product ID, we are looking at the list of comments, and then inside of those list of comments, we only want the third comment. Okay, so that is what it means. So let us look at another example. So we've got the fifth product right here, and then on top of that, we only want the fifth review of the fifth product. Understood? So let us see how we can achieve that in Next.js. So if you're comfortable with how we achieved this particular URL in Next.js, this should be very easy as well. So now let us see how we can achieve this first particular URL. Alright, so let's come to the browser. If I were to add comments, this is not going to show, right? Because we don't have this comments enabled. And even on top of that, if I wanted the third comment or the fourth comment or the fifth comment, even this would not be available, right? So we don't really want the comment list right now. We only want a particular comment ID displayed. All right. So in the previous section, we have already seen how to do this particular path, right? So what did we do? We created a folder called products right here. And then inside of the products, since we are nesting the 15 inside of the products, we created a child folder right here for the product ID, right? So we have to do the same thing. So because the comments is nested inside of the product ID, we have to create another folder called comments right here. Okay, so we have the comments right here. Now, we don't want to list out the list of comments right now. Okay, so I just want you to think about how we can achieve this entire thing. So if I wanted you to hit this particular URL, what you will do is you will be creating a page.tsx and you will be displaying this particular thing. Okay, but right now I don't want you to do that. I want you to think about how we can do, let's say, comments and the 15th comment ID. All right. So to do that, let us go inside of the comments. Okay. So this is a path right here. So we are creating a folder and we've already created that. And this is also going to be a part of the path, right? We're adding something on top of it. So this needs to be a folder as well. Similar to how we did the product ID, we have to create another folder right here called comment ID. All right. Comment ID. So let us follow the same notation that we have right here. And now inside of that, let us create a page.tsx file to specify what needs to be displayed when we hit this particular URL. So to do that, I'm going to use the same snippet again, RAFCE. So now I'm going to call this comment details. All right. And now in this section, I want to display the product ID that has been selected right here. And I also want to display the comment ID selected right here. Okay. So here we can say comment 15 or 10 or whatever of product 5 or 10 or 15 or whatever. Okay. So this takes in dynamic values. As we discussed in the previous section, we will be getting access to the product ID specified and the comment ID specified inside of this particular component through the params object, right? So here you can see that I've specified 15th product and then the 15th comment, right? So if I wanted that, I'm just going to destructure the params right here, and inside of the params, I'll get access to both of these particular variables. So I'm just going to say params dot comment ID, and then right here params dot product ID, save, and let us run this. So as you can see right here, the product ID is getting put here and then the comment ID is getting put here as well. So if I were to change it to the 50th product, you can see that comment 15 of product 50. And similarly, if I were to change this to 60th, you can see that that is getting reflected as well. And we can also get rid of this particular squiggly line by specifying the TypeScript types. So for example, we know that the props is an object, and inside of the props object, we have the params, which is also going to be an object. And inside of that, we know that we have the comment ID here, which is going to be a string. And we have the product ID here as well, which is also going to be a string. And now you can see that all the errors are gone. So in the previous section, we saw how we can achieve these two URLs using nested dynamic routes. But when you're working in a real world project, there might be situations where you might not be able to predict the URLs that your product might have in the future. So in this example that you see, we are basically making the assumption that there is some requirement in your application where a particular comment in a particular product is required. So we were able to think ahead of time and then construct this particular URL, which we saw in the previous section. Let us look at a few more complicated set of routes. So we have localhost 3000 /books/lesson1 /concept1. Each book could have multiple lessons here. It could have lesson 1, lesson 2, lesson 3, lesson 100. And each of those lessons could have multiple concepts sitting inside of it. And similarly, we have books/lesson1 concept 2, we have books/lesson2 concept 1, and we have books/lesson2 concept 2. So in this case, you can obviously make it a lot more simple by just replacing this as the dynamic route and make it as lesson ID, similar to what we did here. And if there are multiple concepts inside of each lesson, we can change this particular part as concept ID as well. So as a result of that, there is going to be 3 levels of nesting happening in the folders, right? So we have the books folder, and inside of that, we will have the dynamic lesson ID folder, and inside of that, we will have the dynamic concept ID. So what if in the future there is another requirement, or rather another path segment that is going to be added to concept 1? So let's say there is examples. So inside of each concept, we only want the second example. So in that case, there is going to be another layer of nesting happening, right? So you can start to imagine that all the folders that we're creating inside of the previous one, inside of the previous one, inside of the previous one, it becomes very inflexible, right? So what if in the future, we just want to remove this concept 1? So we just want books/lesson/example2. In that case, you can imagine that, deleting a particular route folder and then restructuring and rewriting the code is going to be extremely hectic. So in situations where there is multiple nesting happening, using dynamic routes might not be the most efficient solution. So this is where catch all segments come in. So if you do not understand it, do not worry. Let us see it in action. So let us create a folder for books. So inside of books, I'm now going to create a catch all route. So this catch all route is going to have a very special syntax. So I'm going to create a square bracket, and then inside of the square bracket, I'm going to put 3 dots right here. And I'm going to call this slug. So the slug is just a convention and it just means the URL. Okay. And to represent this particular catch all segment, let us now create a page.tsx. and we can call this books route. Okay, so I can just call it, this is the books route. Now, if I go to the URL and then say books / let's say lesson 1, it is always going to show this particular text that we have right here. So it does not matter how many segments that we add to it. So it could be concept 1 or it could be example 100 or whatever. It is always going to show this particular text because all of these routes are getting catched by this particular catch-all route. Understood? As long as the path has this books here, it is going to come inside of this, and whatever is mentioned here, it is all going to be caught by this particular catch-all route. Simple. So now you can see that even though there are multiple segments here, there is no nesting required right here. So we are just increasing the intelligence of this one particular component such that this component has the intelligence to handle every single thing. So even if the user were to just enter book / lesson 1, we just add some logic to this one component such that it knows exactly what needs to be displayed right here. So in this case, it will just say you are in lesson 1. Okay. So if I were to add concepts 1, let's say, it will now say you are in lesson 1, concept 1. So if I were to add example 100, it will now say you are in lesson 1, concept 1, example 1. So this component is going to have all of that intelligence. So no nesting required. Let us now go ahead and add these conditions. So for this, we again rely on this params object. So we have the params object right here. Let us define the TypeScript types here as well. So this we know to be the props object, and then the params is also going to be an object. And inside of this, we have the slug. And what is the data type of the slug? It is going to be a string of arrays. So as you see right here, these 3 path segments that come right after books, right? So we already know that the books is going to be a constant. That is why it came inside of the slug itself, right? So after it comes inside of the slug, it basically just sees what are the segments that are available after books. So the slugs array, so this is going to be an array of 3 strings right here, because as you see, we've got 3 items right here. So this is going to be the first item of the array. This is going to be the second item, and this is going to be the third item. If the user did not enter example, now the array is only going to have 2 items. So depending on this, we can add the conditions. First off, let me extract the slug from the params object. So we have the slugs array right here. So we can now say that if slug.length is equal to 1, it means that, what does it mean? If the slug.length is equal to 1, it means that the slug is only going to have lesson 1. So in this case, we can just display the text, you are in lesson 1. So let us do that. So we can return you are in. So for lesson 1, let's try to make this dynamic. We can say slug of 0. Let us test it out. So now you can see that it says you are in lesson 1. So let us try to add, let's say concept 1. It is defaulting to this particular thing, which we do not want. So let us do this. So we can say slug.length is equal to 2. So if that is the case, we want to say you are in. So let us first say you are in lesson 1 or 2 or whatever that has been mentioned here. And then also say concept 1 or 2 or 3. So if I save it and I refresh it, you can see that it says you are in lesson 1, concept 1. Understood? So it does not matter how many segments that are added. We just make changes to this particular component alone. We don't have to go and change all of the folder structures. So this is particularly helpful if we do not know how complicated the path is going to be when you're beginning to work on the project. Okay. So let us try to do the example here as well. Example, let's say 4. So in this case, we can now say if slug.length is going to be 3, we can say, we can pretty much use the same thing. And then you can just say slug 2. So now you can see that it says example 4. If I were to remove this, it does not show that because it defaults to this particular condition right here. Understood? So there is one more thing that I want you to take away from this section. So let's say I remove this concept 1 and I remove this lesson 1 as well. Let's press enter. And you can actually see that it shows the 404 page. And the reason why it shows that is that this catch-all segment is only going to be activated if there is more paths added to it. It could be anything, right? Only if there is an additional segment that is added to this books right here, only then this will get mapped to this particular value. But if you want the same component to be displayed when this path is hit, you just have to change one thing. So all you have to do is rename this particular slug right here. Okay, I'm going to click on rename, and I just want you to wrap this with another square bracket. So let us update the imports as well. So this is now called optional catch-all segment. So let us try to run it again. So now you see that it cannot read the properties of undefined reading length, and this throws an error. All you have to do is make it an optional chaining right here. So if I just do this, everything should work fine. So now you can see that even if I were to not add any of the additional path segments to the books, it still defaults to the last condition right here. So this would still work. If I were to add lesson 1, it shows you are in lesson 1. If I were to add concept 1, it shows that, and it does not matter how many that you add, as long as the condition exists, it will show. So now I hope you understood how we can use catch-all segments to simplify the way we write routes. So far, we have seen quite a lot of features when it comes to routing in Next.js. So we still have a few more concepts that we need to discuss, which we will talk about in the next section. In this section, let us see how we can efficiently do project organization. So especially if you're working in a huge project, there could be n number of folders and files. So it will help if you have certain conventions that you follow. So Next.js itself does not enforce any project organization rules, but it does provide conventions. So it does provide some best practices. In this section, let us talk about the first convention, which is called safe collocation. So this might not be a word that you might be familiar with. So to put it very simply, what it means is that it is having related methods or components nearby. If you do not understand it, don't worry. Let us look at an example. So let us say I want to create a new route for dashboard. So when the user hits dashboard, what I want displayed is a progress bar, and then we can also have something like a data table. All right. So we want two components here. We want a progress bar, and then we want a data table right here. All right. So let us jump into the code. So to achieve this, what I'm going to do is create a folder called dashboard. So let us do a quick recap. If I have just created a folder called dashboard right here, and if I try to reload this, so as you can see right here, I've saved the code, and even if I reload it, you can see that this page is still not found. And the reason for that is, as you can remember, only if we add page.tsx inside of this route folder, only then it will be accessible, or else it will not be accessible. Okay, so let us create another component right here. Let's call it progress bar .tsx. So I'm going to use the same snippet rafce, and I can just call it, this is the progress bar. Now, as you can see here, we've default exported the progress bar. So even though I've created a default exported component, if I go back here and refresh it, it will still not be available because there is no page.tsx inside of the dashboard folder. So let us now create that. So I'm going to use the same snippet again, rafce. I'm going to call this dashboard. I can call this is the dashboard. Now, if I refresh it, you can see that now this particular route is accessible. And the reason for that is we now have the page.tsx file. So now that I've created this page.tsx file, if I want to import the progress bar component inside of the main dashboard component, I can easily do it. So I can just remove it, and then I can just say progress bar, and it is going to recommend it. And now I can import it, right? I can now import it. And if I were to go back here, you can actually see that it says this is the progress bar. So what are the takeaways right here? So the takeaway is that, so whatever component that this dashboard might need, right? So we have progress bar right now. We can have, many different components. We can have a data table, we can have something else, right? So whatever that this main dashboard might need, you can safely have them created inside of this folder itself. So if you want a data table, you can just create a file called data table, right? So this is going to be another component, and you can define it right here and then import it inside of the main dashboard. And this will be very safe. No user will be able to access these particular files or these particular components. The user will only be able to access the page.tsx. So that is what is meant by safe colocation. So whatever the page.tsx might need, you can safely create and maintain those folders inside of the route folder itself. Okay, it is very safe, and it is not accessible by the user. Only if you import these components inside of the page.tsx file, only then it will be accessible. So they are very safe. You can have pretty much anything that you want. So we can have something called format date or something like that. TSX, you can have some util methods right here, and still this is going to be safe. The user cannot access it. So now I hope you understood what safe colocation is. In the next section, we will see what the second convention is. So let us now look at the second convention, which is private folders. So these folders or its subfolders will not be considered by the routing system. If you want to create a private folder, all you have to do is start the folder name with an underscore. Let us illustrate this with an example. Earlier we saw that we had created a components folder outside of the app folder, right? So let's remove this. Okay, let us remove this. Now what I want to do is I want to move the components folder inside of the app folder. So to do that, I'm going to create a private folder. So I'm going to say components, but we also saw that to create a private folder, we have to use the underscore right in the start. Okay, so let's press enter. And now let us go ahead and create a page.tsx file. Okay, and we can call it something like components. Okay. Now, if I were to go to localhost port 3000 /_components, I should be able to see this particular text, right? So let us try it out. So I'm going to go to /_components. It is throwing a 404 error. And the reason why this is happening is because this folder is a private folder. So whenever you start a particular folder with the underscore, this will not be considered by the routing system at all. It will be completely invisible. So because this particular folder's contents are not available to the user, we can use these private folders to keep whatever util methods or UI components or anything that you want. So for example, I can create a button component right here called button.tsx, and I can define it right here. I can even go ahead and create a utils private folder, and then I can create let's say a format date method, right? And then I can define the format date function right here. So once I define it, I can just use it and import it in other components. And that is it for private folders. We'll move on to the next one. So in the previous section, we saw how private folders work. So let us now look at the third convention, which is called route groups. So basically route groups allows us to logically group routes and project files without affecting the URL path structure. So to illustrate this, I want to create 3 different routes. So I want to create a change password route. Okay, change password route. I also want to create a login route, and I want to create a sign up route. Okay, so let us quickly do that. So if I want to create new routes, I'm going to come inside of the app folder, and I'm going to create the first route. So let us create a route for login right now. Let us go ahead and create another folder for sign up. Sorry, this is supposed to be a folder. So let us go ahead and create a folder for sign up. And let us also create a folder for change password. Okay, so change password, or we can call it forgot password. Okay, let us also create page.tsx files inside of these 3 different folders so that we can show some UI when we go to those particular paths. So what I can do is I can create a page.tsx inside of this, create a component, let us name this forgot password, and we can just give a little bit of a space right here. And let us do the same thing for the other auth routes as well. So let us do another page.tsx for this particular auth route. I can just copy this, put it here, just change the name to login. Let me change this as well, login page. And similarly, let's copy this. And then let's go to the sign up auth route, create a page.tsx file, paste it, sign up. So if I were to go to sign up and then hit enter, you can see that it works fine. The same thing for login as well as forgot password. So I want you to notice one thing. The three paths that we've added, namely the forgot password path, login path, and the sign up path. So if you look at these three folders, they are very spread out, right? So it is not really readable. So wouldn't it be so much easier if there is an auth folder, and then inside of that auth folder, we put all these different routes, right? So when we club it like this, wouldn't it be much more readable? Wouldn't the developer experience be so much more better? So let us do that. So I'm going to create a folder called auth. Okay. So I'm going to create a folder called auth. And now I'm going to move all these three different auth related routes into the auth folder. So I can just copy it by pressing Command on Mac or Control on Windows and selecting login and sign up. And then I can move it inside of the auth folder. So now you can see that all the auth routes are much more readable. We can easily find it by going inside of the auth folder. But let's come back to the browser. Here you can see that this forgot password path is not working anymore. And the reason why it is not working is because there is another segment called auth that has been added. So if we want to access this forgot password page, you will have to add the auth right here. Okay. So now you can see that it works fine. We can also do the same for login and sign up. But what if I do not want this auth segment right here? Okay, so since we're talking about authentication, this could be a valid scenario. But what if there are other scenarios where, in analytics or marketing, you do not want those things showing up here. But for developers, it would still be useful if some related route folders are clubbed together. So how can we remove this while still having this clubbed thing? So if you want to do that, all you have to do is rename it and add this particular brackets right here. Okay, so that is it. Press enter. Update the imports. So now if I go back to the browser, it says that it is not available. Let us try removing this auth right now. And now you can see that it is working fine. Similar to how it was working even before. I can go to sign up and it works fine. Okay, it is not even considering this auth. It is purely for the developer experience. So this is what is called route groups. Okay, a route group just allows us to logically group routes and project files without affecting the URL path structure. I hope you understood what route groups are. I'll see you in the next section. In this section, let us look at what layout.tsx actually does. So if you come into this particular file, you can see that at the very top, we have the metadata. So we will talk about what this metadata does in the future sections. So for now, let us just focus on this component. So what is this root layout used for? So let us say there is one particular section. It could be the header section. It could be the footer section. We would ideally want those sections to be visible across all the different pages, right? It could be the home page. It could be the contact page. It could be the whatever page, right? You want the header to be visible everywhere. So if there is some section that you want visible across every page, you can use the root layout for that. So how does it work? So this root layout wraps any different page that is rendered on the screen. So for example, if the user enters a localhost port 3000, we know that this home component is going to be rendered. But actually what happens is that this home component is passed as children right here. And then this children is the home component. And that is what is getting rendered right here. And similarly, if the user were to go to contact route, so the contact page.tsx component is going to be passed inside of the children. And that is going to be rendered right here. So root layout is the root level or the topmost level component. So if I were to specify a header right here, okay, let us call it header. We can give it some basic styling as well. We can give it a background color of, let's say, green, and then we can also give it some padding of, let's say, 1 rem. Let us take a look. And as you can see right here, we've got the header component. Okay, so this is not really a component. This is just a JSX element for now. But the idea is that this header element is going to be across all the pages that you see. So for example, if I were to go to the home page, you can see that the header is still there. If I were to go to what other page is there, if I were to go to contacts page, you can still see that here. Okay, so I can just do the same thing for the footer as well. So let's change it to footer and let's convert it to, let's say, light blue. Let us also convert the text to footer and let's go back to the browser. And now you can see that this header and footer is present across all the different pages. So if I were to go to about page, you can see that this changes, but the header and the footer remains the same. So let us also take a look at what is happening under the hood. So if I were to inspect what is happening here, so right now you can see that there is a HTML lang is equal to English. And that is exactly what you can find right here. Because the root layout wraps whatever route is currently represented. So in the next few sections, we'll see how we can add some header nav links and then programmatically navigate between different routes, as well as we'll also see what is the significance of the metadata. That is it for now, and I'll see you in the next section. Before we learn more about navigation and programmatic navigation using Next.js, we first have to understand an important concept called React Server Components. React Server Components is a new architecture introduced by the React team in version 18, which Next.js was very quick to embrace. This architecture introduces a very new way of creating React components, and we can split them into two types. So we've got the server components and we've got the client components. So as we progress through the course, we will learn much more about client and server components, but on a very high level, I want you to remember these very important points. Okay, so in Next.js, all components are server components by default. Server components may have the ability to run tasks like reading files or fetching data from a database. However, they do not have the ability to use hooks or handle user interactions because they are on the server side. All right, let's now talk about the client side. So to use a client component, you have to add use client at the top of the component. Client components cannot perform tasks like reading files, but they do have the ability to use hooks and manage interactions. So by understanding these points, there are certain concepts in the future sections that you will easily be able to understand. So I'll see you in the next section. So in this section, let us see how we can do navigation in Next.js. So far, what we have been doing is that to go to different pages, we have been manually changing the URL. So for example, if I wanted to go to the home page, I'm manually removing it and pressing enter. If I want to go to the about page, I'm manually entering it. But in a production application, we have links in the page, and then the user can click on those links and go to different pages. So in this section, we'll have 3 links in the header section. So we can have a home link, we can have an about link, and we can have a products link. All right. So there are 2 ways of doing it. Let us see the first way. So instead of this header, okay, let's change it to, let's say, yellow. Okay. And I want to introduce a nav right here. Now let us introduce an anchor tag. Okay, this first anchor tag could be home, and then let's give it a href, and the href could be home as well. Similarly, we can also have another one, and here we can say about page, right? Or we can just leave it as about, and in the href, we know that the link should be /about. So let's give /about, and we can also pick products page right here, and then we can do the same thing for products as well. So it's going to be products with an S. So because we have an S right here, and then let's give it products list. All right. Now, if you go back here, we can see that currently we are in the about page. If I were to click on the home page, you can see that we are being taken Okay, it is showing a 404 because we are supposed to have this as the root path. So let us click on the home again, and now you can actually see that welcome to the home page. So if I were to click on the about page, you can see that it is changing. Similarly, the product list. So what we've used in the code is that we are using the anchor tag to do the navigation, but there is a huge disadvantage when it comes to using the anchor tag. So what ends up happening is that every single time we go to a different page, an entirely new request is made to the server, and then all the HTML, CSS and JavaScript files are being fetched for every single page, which is very undesirable. And I'll show you what that means. Let us go to the inspect, go to the network tab. If I were to go to the about page, you can see that the entire about page is getting fetched right here, okay, including the HTML, CSS and everything else, right? So if I were to go to the product list, you can see that the entire products HTML is getting fetched. Same thing for the home page as well. But this is not the most optimal way to do things. So for example, a navigation bar is always going to be constant. Let's consider Amazon, for example. The navigation is always going to be there. It is not going to change at all. So in that case, fetching the entire HTML, CSS is not the most optimal way to go. But what we do need to fetch is just the JSON data. That is it. So this anchor tag is going to make requests to the server completely fresh for every single page that we go to, which is not ideal. So which is why Next.js offers a way to do client-side routing. And to do that, we can make use of the link tag. So let me go ahead and import the link tag first. Link from next/link. Let me copy this link and then replace the anchor tags with the link tag. Okay. Now, save it, come back to the browser and let us see what is the difference. You can see that we're in the about page. If I were to go to the products list page, you can see that this HTML, the entire HTML is not getting fetched. The browser is fetching something else, but this is not HTML, CSS or anything. This is a very lightweight request, which Next.js has to do. But as you can see right here, we are not fetching the HTML and CSS. So even if I were to move to home, you can see that home is not getting fetched, or the HTML, CSS, JavaScript files are not getting fetched. Same thing for about as well. The same thing happens. All right. So the link tag allows us to do client-side routing. So now that we've done this, let us do a slightly more complicated routing. Let us go to the product list. And then every time I want to click on the product 1 or the product 2 or the product 3, I want the application to take me to the product details page. So for example, if I click on product 1, it needs to go to this particular route right here, right? Products/1. It should show me the details of the product 1 page. So let us see how to do that. So let us go to the product list page right here. And what I'm going to do is I'm going to wrap the product 1 text with link tags. Let us add a href to this as well. So this is going to be products/1. And let's repeat it and then remove it and then change the numbers right here to 2 and 3 and the same thing here as well. So it is showing a squiggly line because we have not imported the link tag. Next/link. All right. So let's give this a whirl. So if I go to, let's say, product list again and then click on product 2, you can see that the product 2 is listed. So I can go back now and then click on product 3 and then you can see that the details of the product 3 is listed. But you might have noticed one thing. You can see that we have hard coded all the product IDs, right? But in a production application, we might have hundreds and thousands of products and we would ideally want to dynamically generate these hrefs. So in that case, what you might do is, if you're comfortable and familiar with React, in a product list, we'd normally get a product list array, right? What we might do is we might loop through it and then generate each of these links. So as we are looping through it, in each of the product object, you might have access to the product ID. So in that case, what you can do is you can just change it in a way it is dynamic. So for example, let us wrap it with a string literal right here. And then instead of this 1, which is hard coded, I can choose to make it dynamic and then I can insert the ID. So by doing it this way, we can achieve the same output. So this is how it might potentially look like. So we are looping through the product list and then this product object might have the ID and the title. By doing it this way, we can make this dynamic as well. So let us do a quick recap. We can see that the navigation in Next.js is done using a special link component and not the anchor tag. So some of the advantages of link component would be it stops the request to the server, therefore handling the routing in the client side itself. In other words, also called client-side navigation. So whenever Next.js sees a link component in the page currently displayed, it automatically prefetches the page. So what this means is that, so let me refresh it. So even though we are right on the root path, which is the home page, because the about links and the product list links are already present or displayed on the page, Next.js would already fetch both of these pages so that when the user clicks on each of these links, it is already preloaded and prefetched. And that is it for link navigation. In the next section, we will talk about how to programmatically navigate using Next.js. In the previous section, we saw how to navigate using link tags, as we saw right here. So in this section, we will see how to programmatically navigate. So what does it mean by programmatic navigation? So to explain this, I have created a component called checkout. So in this checkout component, we have a div which says checkout page. We have a button here as well, which is place order. Okay, so let us go to the checkout route first. So if we were to go to checkout route, so before we proceed, I want to remove the header and the footer because it can be a little distracting. So let me just go back to the layout and comment it out. Now, so we have the checkout page. So you might have seen this thing in Amazon where if you go and place the order, it might take like 4 or 5 seconds for the order to go through. And then after the payment is done, it automatically goes to the confirmation page, right? So there is no clicking happening, but automatically it gets navigated to the confirmation page. And that is what is called programmatic navigation. So let us see how we can do programmatic navigation using Next.js. Now, let us come back to the checkout page. So right here, let us attach a click handler. Let us call it handle click, and we can define it right here as well. Okay. And we can just say user has purchased. Okay. So if you come back here, you can actually see that event handlers cannot be passed to the client component props. If you need interactivity, consider converting part of this to the client component. So if you remember the video where we talked about client and server components, we saw that every component that we write in Next.js is by default going to be a server component. But because we are using on-click handlers, which is purely a client-side phenomenon, we have to explicitly specify that this component is a client component. Okay. So to do that, come up to the very top and then specify use client. And when you do that, you can see that the error goes away. So as soon as the user clicks on the place order button, I want the user to be redirected to the confirmation page. So redirect to the confirmation page. So to help us with this, let us go ahead and use the use router hook. So import use router, and you have to require it from next/navigation. All right. So to use this use router, first thing is to invoke this function and store it in a constant. So you can call it a router, and then you basically just invoke this particular function right here. So we've got the router object right here. So using this router object, you can actually programmatically navigate. So I'm going to say router dot push, and then I want to push the confirmation page. So since we do not have the confirmation page yet, let us quickly go ahead and create that as well. So confirmation, and then let us create a page.tsx for that as well. So I'm going to use the snippet RAFCE, and let's call it confirmation. All right. Now let us actually test it. As a user, I'm going to click on the place order. And as you can see right here, the /confirmation is getting pushed to the browser stack. We are pushing a new path to the browser stack. So the router object does not only give you access to the push method. So for example, it gives you access to the replace method. It also gives you access to the forward method and then the back method. So what does this replace method mean? So we already saw that push method pushes a path to a stack. The replace method does not push anything, but rather it replaces the entire stack with this particular path. So for example, let us come back. Now you can actually see that we are able to come back from the confirmation page. But if I were to use replace right here, if I place order, you can actually see that I won't be able to come back, but rather it takes me to the root page. It replaces all the paths in the history stack. So we can also use back method as part of the router. The back method programmatically navigates you to the previous page. Okay. Similarly, the forward method programmatically navigates you to the next page that is in the browser stack. One more thing that I want you to note is that when we used push or when we use replace and when we use confirmation, it is not limited to paths like this. You can also use dynamic path, right? You can pass in an ID in a certain scenario and then you can dynamically push a certain route as well. So I hope you now understood how programmatic navigation works in Next.js. I will see you in the next section. So far, we have learned several routing concepts. Now I believe that you have a pretty solid foundation when it comes to routing. So with that said, let us now move on to the next most important section in Next.js, which is rendering. Rendering is the process of converting React components into HTML elements that the browser can understand and display to the user. Okay, very simple. But you can also imagine that this process of converting the React components into HTML elements might take some time, right? So this process of rendering takes some amount of time. Why does it take some amount of time? Because React components are at the end of the day just JavaScript. So this JavaScript is what is getting executed and the HTML elements are getting generated. So that process takes some amount of time. But why is it important for us as developers to understand this process of rendering better? So you need to know where to do the rendering based on the needs of the business. Okay, so do you render a particular section of the website on the client side or the server side? Because at the end of the day, developers are hired to build performant products. And depending on the business requirements, you need to take a call whether the processing is better done on the client side or is better done on the server side. So in the next few videos, we will look at what is client-side rendering, what is server-side rendering, what is React server components. And not only is it going to help you with building performant applications, it is also going to completely set you apart from the rest of the developers. So understanding rendering is crucial for differentiating yourselves from junior or mid-level developer to a senior developer. And I also want to emphasize that if you do not understand a particular concept, do rewatch the video because it does take a little bit of time for things to click. So I would urge you to rewatch it if you do not understand something. All right. So let us now in the next section understand what CSR is or client-side rendering is. So in this section, we will look at everything there is to know about client-side rendering. So on a very high level, majority of the processing is done on the client side. So here's a representation. So as you can see right here, the majority of the processing is done on the client side, whereas the server does not do as much work. And if you've worked with React in the past, then client-side rendering is what it does. So before we jump on to how Next.js does client-side rendering, first, let us understand how React does it and how it has evolved so far. All right. So as you can see, we have the client right here and we have the server. And we know that the code that we've written is based on React. No frameworks, no Next.js, just a basic create React app application. All right. So initially, when a particular URL is hit, a request goes to the server. So what does the server return back? The server is going to return an HTML page and a reference to a JavaScript. Okay, this HTML page is only going to have an empty div, an empty root div. That is it. After the browser receives the HTML, it looks at the JavaScript reference. The browser requests the JavaScript file. So this JavaScript file is going to have everything that the application needs. So for example, the application code that you've written, React library itself, and everything else that is required. And next up, the server actually sends the JavaScript file to the browser. And this JavaScript is actually what is responsible for injecting all of the HTML elements inside of the root div. So earlier I told you that this is going to have a root div, right? So this JavaScript, as and when it is executed, it is going to inject all of the UI elements, all the nodes and all the HTML elements inside of the root div. And soon enough, I'm going to show you how it exactly works in the browser as well. But on a very high level, just understand this. All right. So what happens next? So this JavaScript starts executing in the browser, right? So this is where the HTML generation happens. So what you can take away from this is that the majority of the processing happens on the client side. The server, it is just serving the files. That is it. But this is what takes the majority of the time because this is the rendering part. The client side is where the rendering happens. All right. So now let us actually look at how things work in a real browser. So if you see right here, I have just created a simple create React app project and I've started the server. All right. So let me refresh the page. All right. So now you can see that the first thing that we're getting is the local host. The first request that we get is the HTML plus JavaScript reference. So if you see right here, so we've got a lot of meta link. You can ignore all of this. Let's come to the body tag. And here you can see that we have an empty div right here, right? None of these things that you see right here is actually present in the initial HTML file that we get, right? It is just an empty div. All right. But you can see that there is a script that is attached right here, right? So the script points to bundle.js. So this is the JavaScript file. So as the browser starts parsing this initial HTML, it then looks at this one particular thing and then calls this bundle.js. So it is inside of this bundle.js where all your application code, all your components, even the React library itself is going to sit inside of it. Okay. And when the browser executes this bundle.js, that is when the JavaScript injects all of these elements that you see right here. So that is what is meant by client-side rendering. Most of the rendering happens on the client side. So the definition of client-side rendering is as follows. Client-side rendering is when a component code is transformed into UI within the browser. So in other words, the rendering process happens in the client and not on the server. And we also know that React, which is a popular library used for single page applications, make use of client-side rendering. So even though client-side rendering is very powerful and it has provided a very solid foundation for all the modern websites that we see in the world right now, still developers started seeing a lot of drawbacks to client-side rendering. So what are they? Firstly, performance. Here, because the browser does all of the work, namely fetching data, computing the UI, making HTML interactive, the user side of the experience might be a little slow, correct? So initially the user might only see a blank screen or a loading spinner until the rendering process is done. And as more and more features are added, the JavaScript bundle size is also going to increase, right? It is further going to increase the user waiting time. So performance is the first problem when it comes to client-side rendering. Let us look at the second one, SEO. Generating HTML that only contains a div tag at the start is not best for SEO as there is no content for the search engines to index. So because it takes some amount of time for the content to actually be present in the browser's DOM, search engines might actually miss out on this particular content. And because of that, SEO takes a hit. So because of these two drawbacks of client-side rendering, developers came up with a better way of doing rendering, which we will talk about in the next section. Let us do a quick recap on what we learned in the previous section. We saw that in client-side rendering, since we're solely relying on JavaScript for rendering content on the browser, SEO takes a hit because search engines like Bing, DuckDuckGo, these search engines struggle to index the page. We also talked about the slow loading times. User experience suffers as the browser has to download, parse, execute the JavaScript before the user sees anything on the screen. The user's device has to do everything, right? So to combat both of these drawbacks of client-side rendering, a lot of frameworks like Gatsby, Next.js, they have embraced something called server-side rendering. We'll see what that is. So on a very high level, majority of the processing or rather rendering is done on the server side, not on the client side. Let's see a simple representation. So it is going to look something like this. So as you can see right here, the client does not have to do as much work compared to the server. So let us now actually see a representation of the calls. We have the browser on the left side and we've got the server on the right side. So the browser as usual makes a request to the server. And since we're now talking about server side rendering, what ends up happening is as soon as the request comes to the server, the HTML is generated on the server side. Okay, and then we've got the full HTML plus a JavaScript reference getting sent back to the client. I want you to properly take note of this. We are actually getting the full HTML, right? In client-side rendering, we saw that we only get an empty HTML. But since we're talking about server-side rendering right here, we are actually getting the full HTML because the server is generating the entire HTML. The advantage here is that the user is able to see the full HTML page instantly. And the reason why it is so instantaneous is because the browser only has to parse the HTML, that is it. There is no JavaScript getting executed. So the user can now see the full UI. But one more thing that I want you to take note of is that it is going to be non-interactive because the JavaScript has not reached yet. Okay, we only have the JavaScript reference right here. So the UI is going to be non-interactive. This effectively solves both of the disadvantages of client-side rendering. So we'll see what that is. So what are the advantages? We see that SEOs improved because search engines effortlessly index the server rendered content as they don't have to execute JavaScript. And when we talk about performance, user's device immediately shows the HTML content and not a blank screen because all the processing and rendering is done on the server side and not on the client side. But there is a small disadvantage to doing server-side rendering. Note that even though the content is visible instantly, it is not interactive for the user. See, it is going to be a non-interactive UI. And the reason why I say that is because at this stage, the JavaScript is not really present in the browser. Only the HTML is present in the browser. So now, as the browser parses the HTML, it is also going to make the JavaScript request. And after the JavaScript comes to the browser, it is only then when the UI is made interactive. And the process of making the UI interactive is called hydration. Hydration is a very important thing that you have to understand. So let us actually look at what the definition of hydration is. Okay, so during hydration, React takes control of the browser, reconstructing the component tree in memory based on the static HTML that was served. It carefully plans the placement of interactive elements within this tree. Then React proceeds to bind the necessary JavaScript logic to these elements. And this involves initializing the application state, attaching event handlers for actions, such as clicks and mouse overs, and setting up any other dynamic functionalities required for a fully interactive user experience. So I really want you to internalize this concept of hydration because this is going to come in very handy. So now that we have seen on a very high level what server-side rendering is, let us now see the types of server-side rendering. So first off, we have the static side generation, and secondly, we have the server-side rendering. So SSG or static site generation occurs at build time when the application is deployed on the server. This results in pages that are already rendered and ready to serve. It is ideal for content that does not change often, like blog posts. SSR, on the other hand, renders pages on demand in response to user requests. It is suitable for personalized content like social media feeds where the HTML depends on the logged in user. SSR was a significant improvement over client-side rendering, providing faster initial page loads and better SEO. So I want you to understand this on a very high level. We are going to understand how all of this works in code later. But for now, I want you to understand on a very high level what these two types mean and what are the definitions. There are a few drawbacks to SSR as well. Let us look at what they are. On the server side, components cannot start rendering and then pause or wait while data is being loaded. If a server component needs to fetch data from a database or another source like an API, this fetching must be completed before the server can even begin rendering the page. This can delay the server's response time to the browser, as the browser must finish collecting all of the necessary data before any part of the page can be sent to the client. The next drawback is for successful hydration, where React adds interactivity to the server rendered HTML, the component tree in the browser must exactly match the server generated component tree. This means that all the JavaScript for the components must be loaded on the client before you can start hydrating any of them. Now coming to the final drawback. React hydrates the component tree in a single pass, meaning once it starts hydrating, it won't stop until it's finished with the entire tree. As a consequence, all components must be hydrated before you can interact with any of them. Because of a mix of all these three different types of drawbacks, namely having to load the data for the entire page, load the JavaScript for the entire page, hydrate the entire page, it ends up creating an all or nothing waterfall problem that spans from the server to the client, where each issue must be resolved before moving on to the next one. This can be inefficient if some parts of your app are slower than others, as is often the case in real-world applications. So because of all of these drawbacks that even pure server-side rendering has, React has come up with a different server-side architecture. And that architecture solves all of these drawbacks of pure SSR. So in the next section, we will see what that is. In the previous section, we saw all about server-side rendering and also its drawbacks. So we saw that we had that all or nothing waterfall problem. The first problem was that all data needed to be fetched before even beginning to render a page. And the second one was that All JavaScript must be loaded on the client before hydration can even start. And the third one was that only after completing the hydration, the web app will be interactive. So as you can see right here, the first process needs to be done before it can be moved on to the second process. Only if the second process is done, it can move on to the third process. So before the user can actually see an interactive website, each step needs to be completed, right? So these issues results in an all or nothing waterfall problem causing delays. And this problem is very visible if some parts of your app is slower than others. If you're wondering how these 3 steps play out in the real world, let me give you a practical example and also what is the solution for it. So let us take an example. So I've created a component right here. So this page component that you see right here is sitting in the root page.tsx. If you see inside of this, we have the layout wrapping a lot of different components. Inside of that, we have the header, we have the site nav, the main section and the footer. So if I were to request this particular page from my browser, it would look something like this, right? So I'm not focusing on CSS right now. One more thing, I also want you to note that this is a server component. If you remember, every component that you see in Next.js is by default a server component. So if I'm actually requesting this particular page from my browser, the server is actually rendering this entire thing and then it is sending the HTML to the browser. Okay, so if I were to go to network, you can actually see that I am actually getting the full HTML right here. Okay, the full HTML. Now, let us actually look at the first problem that we see right here. All data needed to be fetched before even beginning to render a page. Just to jog your memory, we know that when the request comes from the browser, the server is actually going to render this particular component, generate the HTML and send it to the browser, correct? But to even start rendering the page, all the necessary data needs to be fetched. Okay, so if you come right here, what is the data that needs to be fetched? So we have the header. There is no data required to fetch, right? Site nav is also very simple. Similarly, the footer component is also very simple. There is not much data to be fetched. But this main section actually has a lot of data to be fetched. It could be like making an API call. So let us actually go inside of the main section. So right now, I'm just returning a div with the text main section content. What if there is some data that needs to be fetched right here? And what if this takes like 3 to 5 seconds, right? So to simulate that, I've written a very simple set timeout right here. Okay, let us actually make this into 2000 and let us actually try to, let me just leave it at 4000 seconds so we'll be able to see it clearly. Let me refresh this network tab and let me now refresh this page. So as you can see right here, it loads for an entire 4 seconds. Even though it only takes like barely like a couple of milliseconds for the header and the site nav and the footer to load, because of this main section, because of this one component right here, which takes 4 seconds, the entire page is taking 4 seconds to load up. That is the main disadvantage that we saw right here. All data needed to be fetched before even beginning to render a page, which is not ideal. Wouldn't it be great if there was some way to tell Next.js, do not wait until the main section is completely fetched. Whatever is loaded, render it, convert it into HTML, send it to the client, right? So to do just that, we have something now called suspense. Okay, we know that main section is the bottleneck, right? So what I'm going to do is I'm going to wrap this main section component using a suspense component. If I type suspense, you can actually see that it is recommending it. So you can see that it is importing from React. So let me move the main section inside of it. So let us now see this in action. If I were to refresh the page, you can actually see that we do not see that main section content right now, right? It only comes after 4 seconds. So this suspense component effectively solves the first problem. Now we do not need to fetch all the data to render a page, right? So this solves this first problem. But right now, I feel that main section suddenly coming up is a little ugly. Okay, so if I were to refresh it, so if I refresh the page, initially I only see the header, side nav and the footer. And suddenly this main section content is showing up, which I do not want. So the suspense component accepts another fallback prop. So here I can actually specify something like main section is loading. Okay, so now if I refresh the page, you can actually see that it says main section is loading, and after 4 seconds, it gets replaced by the content. So this way of doing it is much more pleasing to the eye. I will also show you pictorially what happens. So initially, basically we're just wrapping the main section with a suspense, and then we're adding a fallback, and it can be something like a spinner as well. So initially when the client asks for this particular page, the server is going to render the header, a side section and the footer. And instead of rendering this, because this takes a little bit of time, it is instead going to send the spinner. So the browser is going to show something like this at the start. So after the necessary data fetching is done, the main section is going to be visible. Let us also talk about the second problem right here, which is all JavaScript must be loaded on the client side before hydration can even start. In the previous section in server-side rendering, we saw that the request goes to the server generates the HTML and then sends the full HTML and then the JavaScript reference. And after the HTML alone is displayed, the JavaScript is requested, and after the browser gets the JavaScript, only then the hydration happens. We saw that hydration is the process of making all of the HTML interactive. So the second problem right now is all the JavaScript must be fully loaded on the client side before hydration can even start. Let's go back to our example. So we know that even though this takes 4 seconds to render, the user is still able to see the other sections. But because the full JavaScript bundle has not come yet, I will still not be able to interact with the header section, the side nav section, and the footer section until the entire JavaScript is loaded on the client side. So this is the second challenge. Only after the JavaScript for the main section is fully loaded, client-side hydration can start. If the JavaScript bundle size is very big, this can delay the process. And this is where code splitting comes into the picture. Code splitting allows you to mark specific code segments as not immediately necessary for loading, signaling your bundler to segregate them into separate script tags. Using React Lazy for code splitting enables you to separate the main section's code from the primary JavaScript bundle. So the JavaScript containing React and the code for the entire application, excluding the main section, can now be downloaded independently from the client without having to wait for the main section's code. So let us now lazy load the main section's component, because now the browser will continue hydrating the rest of the components and not wait for the main section. So to do that, let me come down here, create another main section, and then we can use React Lazy. So I can see that the React is not imported. We are importing like this. Okay, let me copy this, put it here, and we can remove this now. All right, so now we have successfully lazy loaded the main section. And now the hydration also continues for the rest of the sections, and it is not going to wait for the main section to be done. And the hydration of this main section happens later parallelly. So this lazy loading of the component that you've wrapped with the suspense is very crucial, because by wrapping the main section with suspense, you have indicated to React that it should not prevent the rest of the page from not just streaming, but also from hydrating. So when you wrap a heavy component with suspense, you're basically telling React the rest of the page must go on. The rest of the page must stream, the rest of the page must hydrate. So this feature called selective hydration allows for the hydration of sections as they become available before the rest of the HTML and the JavaScript code are fully downloaded. The JavaScript containing React and the code for the entire application, excluding the main section, can now be downloaded independently by the client without having to wait for the main section's code. Selective hydration offers a solution to the third issue that we saw earlier, which is the necessity to hydrate everything to interact with anything. React begins hydrating as soon as possible, enabling interactions with elements like the header and the side navigation without waiting for the main content to be hydrated. This process is managed automatically by React. In scenarios where multiple components are awaiting hydration, React prioritizes hydration based on user interaction. So basically what this means is that if the user clicks on this footer section first, React will prioritize hydrating the footer section first. So now, because of the combination of suspense and lazy loading of the main section, we have now successfully conquered all the different drawbacks that we saw earlier of server-side rendering. So the first drawback was data fetching must be completed before the server can even begin rendering the HTML, which is successfully conquered because of the suspense that we used. And then the JavaScript required for the components need to be fully loaded on the client side before the hydration process can start. So this particular drawback is conquered because we are lazy loading the particular component. And also all components needs to be hydrated before they become interactive. This has also been conquered because all the other components are going to be hydrated very fast, and the main section's content is going to be hydrated later on asynchronously. But still there is room for improvement. Let us see what they are. First, even though JavaScript code is streamed to the browser asynchronously, Eventually, the entire code for the web page must be downloaded by the user. As applications add more features, the amount of code users need to download also grows. This leads to another important question. Should users really have to download so much data? Secondly, the current approach requires all the React components undergo hydration on the client side, irrespective of their actual need for interactivity. This process can inefficiently spend resources and extend the loading times and time for interactivity for users, as their devices need to process and render components that might not even require client-side interaction. This leads to another question. Should all components be hydrated, even those that don't need interactivity? Third, in spite of servers' superior capacity for handling intensive processing tasks, the bulk of JavaScript execution still takes place on the user's device. This can slow down the performance, especially on devices that are not very powerful. And this leads to another important question. Should so much of the work be done on the user's device? So to conquer these three drawbacks of Suspense SSR, an incremental improvement is not enough. The React team needed a huge leap. And to solve this, React introduced something called React Server Components. And this is what we'll be covering in the next section. So in the past few sections, we saw all about how rendering evolved in React. So initially we saw that we had client-side rendering, but then it had some drawbacks. So server-side rendering was implemented. But even then, server-side rendering also had some drawbacks. So in the previous section, we saw all about Suspense for SSR. So we've come a long way. Now, Suspense for SSR brought us much more closer to a seamless rendering experience. But at the same time, there were a few drawbacks. So namely, increased bundle size leading to high downloads for the user. Unnecessary hydration delaying interactivity. Extensive client-side processing that could result in poor performance. So to solve these drawbacks, a small incremental improvement is not enough. The world needed a much bigger leap. And that is exactly what the React team did. The React team introduced something called the React Server Components. So let us see what it actually stands for. So React Server Components, or RSC, represents a new architecture designed by the React team. So this approach uses the strengths of both server and client environments, optimizing for efficiency, load times, and interactivity. This architecture introduces a dual component model. We have the client components and we have the server components. This distinction is not based on the functionality of the components, but rather on where they execute and the specific environments they are designed to interact with. So to put it very, very simply, client components are the familiar React components that we've been using so far. Okay, simple. They are typically rendered on the client side, but they can also be rendered to HTML on the server, allowing users to immediately see the page's HTML content rather than a blank screen. The idea of client components rendering on the server might seem a bit confusing, but try to view them as components that primarily run on the client, but can and should be executed once on the server as an optimization strategy. Client components have access to the client environment, such as the browser, allowing them to use state, effects, and event handlers to handle interactivity, and also access browser exclusive APIs like geolocation or local storage. So if this is complicating it a little bit for you, just know that this is exactly what we've been using while working with React all of these years before the introduction of the RSC architecture. In fact, the term client component does not signify anything new. It simply helps differentiate these components from the newly introduced server components. So let us now see what is this newly introduced server components all about. Server components, on the other hand, represent a new type of React component specifically designed to operate exclusively on the server. And unlike client components, their code stays on the server and it is never downloaded to the client. This design choice offers multiple benefits to React applications. Let us start with the obvious one: improved data fetching. Server components make data fetching faster. Typically, when fetching data on the client side using useEffect, a child component cannot begin loading its data until the parent component has finished loading its own. This sequential fetching of data often leads to loading delays. There is also an additional round trip made from the client to the server to fetch data, right? So this is where server components come in. Server components remove unnecessary round trips by keeping it localized to the server side. Because of this, request latency is reduced and overall app performance increases, eliminating the client-server waterfalls. Let us look at the next one. Reduced bundle sizes. Server components do not send code to the client, allowing large dependencies to remain server-side. This benefits users with slower internet connections or less capable devices by eliminating the need to download, parse, and execute JavaScript for these components. Additionally, it removes the hydration step, speeding up app loading and interaction. Caching. Rendering on the server enables caching of the results, which can be reused in subsequent requests and across different users. So this approach can significantly improve performance and reduce costs by minimizing the amount of rendering and data fetching required for each request. Let's look at the next benefit. Direct access to server-side resources. By having direct access to server-side resources like databases or file systems, server components enable efficient data fetching and rendering without needing additional client-side processing. Leveraging the server's computational power and proximity to data sources, they manage compute-intensive rendering tasks and send only interactive pieces of code to the client. Enhanced security. Server components' exclusive server-side execution enhances security by keeping sensitive data and logic, including tokens and API keys, away from the client side. Coming to the next benefit. Faster initial page load and first contentful paint. Initial page load and first contentful paint are significantly improved by server components. By generating HTML on the server, pages become immediately visible to users without the delay of downloading, parsing, and executing JavaScript. Let's look at the next benefit. Improved SEO. The server-rendered HTML is fully accessible to search engine bots, enhancing the indexability of your pages. Efficient streaming. Server components allows the rendering process to be divided into manageable chunks, which are then streamed to the client as soon as they're ready. This approach allows users to start seeing parts of the page earlier, eliminating the need to wait for the entire page to finish rendering on the server. So to summarize, server components take charge of data fetching and static rendering, while client components are tasked with rendering the interactive elements of the application. So to remember this as a rule of thumb, whenever there is data fetching required, do it on the server side. And whenever there is some interactivity required on a component, make that as the client component. So for example, in a social media app, interactive sections like the newsfeed and messaging features can be kept on the client side as they require constant user interaction. Whereas static components like the about page, FAQs can be kept on the server side. So the bottom line is that by using the RSC architecture, we take advantage of the best aspects of both server and client rendering, all while using a single language, a single framework, and a cohesive set of APIs. So to summarize, here are the key takeaways of React Server Components. React Server Components introduce a new way of building React applications by separating components into two types, server components and client components. Server components run only on the server, accessing data and preparing content without being sent to the browser, which makes the app faster for users because less information needs to download. Note that they cannot manage clicks or interactions directly. Client components, on the other hand, work in the user's browser and can handle all the interactive parts of the app, like clicking and typing. They can also be rendered on the server for a fast initial load of the site. This setup helps make websites faster, more secure, and easier for everybody to use, no matter where they are or what device they are using. I know that was a lot. We learned a lot about React Server Components. We learned a lot about how React evolved, starting from client-side rendering to server-side rendering and using suspense and server-side rendering. So far we've just been learning about the evolution of rendering in React. So right now you might have a question. So we deep dived into the evolution of rendering in React so far. But you might have a question. How exactly does it help me understand rendering in Next.js? What is the connection? So to answer the question for you, the app router that we saw on Next.js is built exactly around the RSC architecture. All the features and benefits that we've discussed are already baked into the latest version of Next.js. So by understanding the evolution of React's rendering, you now have the necessary background to understand the rest of this section. So in the next few sections, we will be focusing completely on Next.js. In the last few sections, we saw a lot about the RSC architecture. We learned that under RSC architecture, we have the dual component model. We've got the client-side components, and then we've got the server-side components. In this section, let us actually try to practically create these client-side components as well as server-side components and see how they differ from each other. So to do this, I'm going to create a new Next.js project. I'm going to enter in this particular command right here, which says npx create next app at latest, and then the name of the project. So once it is done downloaded, you will see the project structure looking something like this. We already know that in Next.js, all the components that you write are by default server components. For example, the home component that is sitting inside of the page.tsx file, this is by default a server component. Similarly, this layout.tsx file, where we have the root layout, this is also a server component. So to better understand server components, let me go ahead and create a header component. So let's create a folder called header, which is going to be the path name. And then let us also create a page.tsx file inside of it. So let us create a component for this header, and we can use the shortcut RAFCE, and we can rename it to header. And since we know that this component by default is going to be a server component, let us actually test it out, see where it is actually getting executed. So let me add a console log right here saying that header component. So let us actually go to the browser now and go to the header path right here. And then as you can see right here, the log that we had put right here is not actually getting logged in the console, but rather it is executed on the server side. So this is how you know that this component is a purely server component, because the JavaScript bundle is not getting sent to the client at all. Only the HTML is getting sent to the client. So that is why you see that this console is executing here and not here. So because of the fact that this is a server component, the same advantages that we discussed in the previous sections, which is better SEO, zero JavaScript bundle sent to the client, better loading times, etc., all of that apply for server components. But the drawbacks of server-side components is that you cannot use useState or useEffect, and you cannot add any interactivity to these components. So for example, you cannot add any on-click or anything like that to these particular elements inside of the server component. Why? Because they only exist on the server side, and event handlers and everything is a client-side phenomenon. So let me show it to you. So if I try to add an on-click handler right here, right, and I can just like print out something like header. And if I save it and if I try to run it, you can actually see that it says event handlers cannot be passed to client component props. If you need interactivity, consider converting part of this to a client component. Okay, so let's delete that. And to illustrate client components, let me create another folder right here for dashboard. And we can create the page.tsx for this as well. And using RAFCE, we can create the boilerplate. Let's call it dashboard. And let's call this dashboard page. Let me also add a console log right here for dashboard component. So at this point, this component is still going to be a server component. But if you have requirements such that you need to have state, so you might have to import useState, or you might have to attach an event handler to some button click or something like that. In that case, you will have to convert the server component into a client component. So let us actually create a very simple button and add some interactivity to it. So I can just have an H1, put this inside of that, and then let's have a button right here which says click me. So if you want to handle some interactivity right here, so for example, I can have a handle click function written right here, and we can just say button clicked. So now if I try to go to the dashboard route, and you can see that we're still getting the same error. So if you need interactivity, we have to convert it to a client component. And to do that, all you have to do is add one small directive at the very top of the file. So you have to add use client. That is it. So now if I run it, you can actually see that there is no errors. So what is now happening is that this dashboard component alone, it is moving from the server to the client and it is getting executed on the client side. Whereas this being a server component, because there is no use client or any directive used, this effectively just executes on the server side and it is not sent to the client side at all. Okay, so if at all there is some interactivity that you have to use, you have to make it as a client component. Whereas if there is no interactivity or if there is some fetching happening, make sure to keep the component in the server side. But there is one more very important thing that I want you to note. Okay, so you remember that we had added this console log in the dashboard, which is a client component, right? So if I refresh this page, you can actually see that this dashboard component is getting logged properly. And that is the expected behavior, right? A client component is supposed to execute on the client side. So this is the expected behavior. If you were to come back to the terminal, which is on the server side, you can still see that this is getting executed. So you might have a question. We know this is a client component. It is only supposed to execute on the client side, right? No, that is the catch. So what ends up happening is that client-side components do get executed on the client side, but it also gets executed once on the server side initially for optimization purposes, where the HTML is generated in advance. And that is it for client as well as server components. In the next few sections, we will be building a to-do application with complete CRUD operations, and we will also be making the right design choices. So for example, which component needs to be put on the client side? Which component needs to be put on the server side? So by the end of the next few sections, you should have a pretty good idea of how to build production grade Next.js applications. So I'll see you in the next section.